Alright, welcome to today's class. We'll be taking a good look at the alkanols. And of course, there are other aspects of alkanol to be treated, but because of the scope of this class, I'm just going to take you through the primary, secondary, and tertiary alkanol. Now, how do I identify primary alkanol, secondary, and tertiary alkanol? The first thing to do is to check the carbon that carries the functional group, which is the OH. So you check the carbon carrying the OH. Now, after getting that, then you check how many alkyl groups are attached directly to the carbon, or how many carbons are attached directly to the carbon that carries the OH. Now, how many alkyl group? This is an alkyl group, which we can represent with R. So this is an alkyl group. So one alkyl group is attached to the carbon carrying the OH. Or better still, you can check how many carbon is directly attached to this carbon. Directly. This is the only carbon that is directly attached to this carbon. So since there's only one carbon directly attached to this carbon, then it is a primary alkanol. Then for secondary alkanol, still the same method. Check the carbon that carries the OH. Then how many alkyl group are attached to the carbon carrying the OH? Now, this is one alkyl group. This is another alkyl group. Now, it means two alkyl groups are attached to the carbon carrying the OH. This makes it a secondary alkanol. Now, we can as well just check the hydrogen. Two hydrogen are attached to this, to primary. One hydrogen atom is attached to secondary. But it's better you see from the alkyl group. One alkyl group, primary. Two alkyl group, secondary. Then for this, the carbon carrying the OH, how many alkyl group? This is one alkyl group, another alkyl group, another alkyl group. So three alkyl group are attached to this carbon carrying the OH. Hence, this is a tertiary alkanol. So it is simple to know. So the next thing to do now is to go to oxidation of alkanols. Oxidation of alkanols. Oxidation of alkanols. So we have oxidation of alkanols. Now we start with number one, oxidation of primary alkanol. Oxidation of primary alkanol. We use 1 degree to represent primary alkanol. Now, primary alkanol gives two products. First thing to note, especially those of you preparing for JAM, the first product it gives is an alkanol. Then, if you oxidize with excess oxidizing agent, you get alkanoic acid. Alkanoic acid. So these are the two products of the oxidation of alkanol. Now, oxidation of primary alkanol gives two products because it has two oxidizable hydrogen. Secondary has just one product because it has just one oxidizable hydrogen. Tertiary cannot be oxidized because it has no oxidizable hydrogen. This is not just hydrogen, they are members of the alkyl group. So they are oxidized to give two products. So let's check. Now, let's pick anyone. Let's pick this example we have here, which is OH, this, and this. Now, if I am to oxidize this, remember we have several definitions of oxidation. Oxidation could be addition of oxygen or removal of hydrogen. Addition of oxygen or removal of hydrogen. That is one definition when it comes to oxygen and hydrogen. Of course, we have some definition based on electron transfer. But for the purpose of this, we'll be talking about oxygen and hydrogen. Now, here we'll be dealing with removal of hydrogen first. So, if you oxidize this, you remove this hydrogen and you remove this hydrogen. So remember, you must remove two hydrogen atoms because hydrogen are diatomic. So this gives us This gives us, we have, this gives, you have this, so 1, 2, 3, the hydrogen here. Now, for the third carbon, you have removed this hydrogen and hydrogen, so you are left with oxygen and hydrogen. Remember in our previous classes, we said this bond represents electrons, and I explained why you have 4 bonds surrounding every carbon. Please check my previous class. Now, remember oxygen. Oxygen is atomic number 8, arranged as 2, 6. How many electrons does it need to be balanced to attain octet configuration? It needs 2 electrons to be balanced. Therefore, this oxygen is going to be having double bond, then hydrogen here. So you check for carbon 1, 2, 3, 4, the bond is balanced. Then for oxygen 1, 2, the bond is balanced because the bond represents electron. So this now, with this you have propanol, which is an alkanol for the first oxidation. So this is oxidation. The first oxidation of primary alkanol. Then if you oxidize this further, you are going to be getting an acid. So with this now, we will do, this definition is oxidation is the removal of hydrogen. So here we are going to be doing oxidation is the addition of oxygen. Oxidation is the addition of oxygen. So from here we have this. Now we have oxygen here, then you are adding oxygen to this. Remember there are 2 hydrogen formed here, so we have, so that is just like it. So here you are adding oxygen to this hydrogen. So in this case you will form what we call alkanoic acid. So here now we have propanoic acid. Which is an alkanoic acid. So thank you. We'll continue the oxidation of secondary and tertiary alkanol. I hope you understand this. Thank you.